Hello, and welcome to my presentation on the development of a reliable mobile LoRa gateway. My name is Sasandu Wijasuriya, and this research was conducted under the supervision of Dr. Sulochana Soryarachi and Mr. Radarshan Suganeswaran. Let's start with a quick introduction to LoRa. LoRa is a leading low-power wide-area network protocol. It stands out for its ability to connect devices across long distances up to 20 kilometers while keeping power consumption low. Because of these features, LoRa is widely used in IoT systems for agriculture, smart cities, and environmental monitoring. Several factors affect LoRa's performance, including frequency, bandwidth, spreading factor, coding rate, transmission power, and time on air. But among these, the spreading factor is especially critical for balancing range, reliability, and data rate. From the literature, we know that some parameters like frequency and duty cycle are fixed by regulations, while others such as spreading factor, bandwidth, and power can be adjusted. The spreading factor, which can be set from SF6 to SF12, has the most profound effect on range and performance. To test these principles, I designed field experiments using ESP32 boards with SX1278 LoRa modules as sensor nodes and a Raspberry Pi with SX1278 as the gateway. These experiments provided key data on how different spreading factors perform in real-world scenarios. The experiments showed that the spreading factor dramatically affects performance. Increasing spreading factor can triple the maximum range but also increases time on air by about 100 times, slowing down data transfer. But why focus on mobility? In real-world applications, gateways may be mounted on vehicles or drones, not always fixed. LoRa wasn't originally designed for mobility, but it's actually one of the most suitable technologies for it if we can solve the reliability problem. Initially, we tried to design a protocol for dynamically changing the spreading factor based on distance. However, experiments revealed that this approach was slow and inefficient on single-channel gateways, leading to packet loss. One obvious solution is to use multi-channel gateways, which handle different SFs and channels simultaneously. Unfortunately, these are about 20 times more expensive than single-channel gateways, making them impractical for widespread use in countries like Sri Lanka. So, the research question became, can we find the optimum spreading factor for mobile LoRa scenarios using only affordable single-channel gateways to ensure reliable communication? Our objectives were to study how spreading factor affects performance in mobile LoRa networks, find the optimum value for various scenarios, and develop an algorithm using both simulations and practical experiments. To achieve this, we explored several simulators. NS3 was selected for its ability to model real-world mobility and radio conditions. Using NS3, we simulated packet delivery, signal strength, and reliability under various speeds and environments. The algorithm considers many real-world factors: distance, environmental type, mobility speed, interference, battery constraints, and required throughput. Each of these influences the ideal spreading factor for a given scenario. The result is an algorithm that uses a rule-based and weighted scoring approach to recommend the best fixed spreading factor for any mobile deployment, maximizing coverage and reliability while keeping costs low. These rules and weights were adjusted with real-world field testing results and simulation results. Results show that with the right configuration, even single-channel gateways can achieve high packet delivery over 90% in most scenarios comparable to much more expensive hardware. In conclusion, this project demonstrates that with the right algorithm and analysis, we can unlock reliable, scalable mobile LoRa networks using affordable hardware. This is a vital step toward making IoT accessible and impactful for agriculture, environment, and smart infrastructure in Sri Lanka and similar countries. Thank you for your attention. If you're interested in the details or would like to collaborate, please feel free to reach out.